So how do you create an object like this in Fusion 360? And of course I'm referring to this sphere here and not to the leaf structure up top. I'm not going to cover that. That's basically a T-spline leaf or leaf modeled in the T-spline environment and then patterned around. But there's also some patterning going on, obviously, here in this sphere. And the base tile, so to speak, that is patterned is this. So that's what we're going to start with. How do we create this tile? So here is this tile. And that's the basic tile here. And we can see that already here in the image below. And there are several symmetries in this tile. So we have obviously 4 identical legs. And we have a top here. And we have a bottom. And they're also symmetric. So what symmetry is prevalent here? It's basically circular symmetry. So if I create this as a T-spline, and I've already sketched out the polygons, the quad polygons that I'm using for the T-spline, then this is one leg, and that would be either the top or the bottom, so one of those. And then I create a circular pattern, so I have 4 legs. And then if I flip this around this axis on itself, then I have this complete structure, and it needs to be thickened. The workflow is slightly different, but let's see how we do this in Fusion 360. So here in Fusion 360, the first thing I did, I created a sketch with a rectangle here, 10 times 10 millimeters, just so I can size the canvas that I imported. This is that same tile image. And I calibrated the canvas and scaled it exactly to 10 millimeter times 10 millimeter. And then I used this rectangle to visually just center this in here. And we still have our base layout here selected or shown. And then I created a second sketch. And that second sketch basically serves as snapping points for our T-spline geometry. So create a T-spline, create a face on this construction plane, and the important thing here is to turn on object snap, so I can actually snap to that spline, to the sketch geometry. And here we need to be as accurate as we can. The snapping is to line segments, but it doesn't seem to snap to intersection points of lines. And we need to be sure that we are really snapping to the middle here of this edge, because if we later on pattern this, these edges here need to match up in length close enough so that these vertices automatically weld. But we'll probably see what I mean with that. So that snapping is pretty choppy. That's the same also here in these points. They need to divide this edge in half, same here. So I'm going to do the same thing again, scroll in to get this close enough. If we don't get this close enough, that's okay, because we can always fix that later. Okay, so there's our T-spline base geometry, and it turned automatically into smooth view mode, meaning that all the vertices match up and it converts. And of course now it would be a flat surface, but that's not what we need. So I'm going to start editing a T-spline and give it a little bit more of a 3D shape. So that's our base structure. So if we convert this now, obviously that's going to be an infinitely thin surface. That's not what we need. We need thickness. I'm going to apply thickness before I actually create the circular pattern, or am I? No, I guess I'm not. So the first thing I'm going to do now, or the next thing, is a circular duplicate, and there is no indication that you actually now have to select an axis. So there it is. And what I'm going to do now, because that still would be an infinitely thin surface, I double click and edit the form and move this up by 0.25 millimeters. And then I come Control C, Control V for copying it, and move this down by minus 0.5 millimeters. So, and now I'm going to use the bridge tool to connect the two shapes. And I only need one. Okay, so this is connected all the way around. We don't need this here. And so then the next thing that I'm going to do, actually, I have to create circular symmetry again, but I don't have an axis. And what I can't do, I cannot pick any edge here, and I can also not pick any sketch entities. So I actually have to create myself an axis. So I'm going to just use an axis through an edge. There it is. And turn off the sketch, and then I can create another bit of circular duplicate here. And we need two of those, and there we go. So now this is our base structure. So if I finish the form now, it'll probably complain because there's self-intersecting geometry. Yep. So after a bit more modeling, we arrive at a structure like this. And if we switch this to smooth view mode, that's what it looks like. And now it would also convert. But the problem is, of course, it has rounded edges. And I can go back into the T-Spline environment and apply creasing here, but I don't want a crease, I want a smooth surface. And also, if I want a smooth surface, obviously I can't live with this single tile. So the next thing I'm going to do is I'm going to create a pattern with that tile in the T-Spline environment, and then cut out a single tile out of that pattern once it's a surface or solid. So how do we do this? There isn't really a pattern tool per se, like a linear pattern tool in the T-Spline environment. What I can do is what I've done several times already. I can apply circular symmetry. So in order to be able to do this, I needed to create a few little construction lines, point-to-point construction line here through 2 points. Here's one of them, and the other one is there. So let's delete this one, and let's delete this one as well. And just simply show how to do this. Axis through 2 points, and of course that only works in box view mode. And then we create another circular duplicate. By this point in time, you should actually be happy with the geometry of this tile, because the more often you create circular symmetry, the slower the editing will be, because the object now has quite a few faces. And of course, I need to do this again because I need to have a tile that is surrounded by tiles on each side, so that these surfaces, these adjacent surfaces, when I pattern this as a solid or a surface, are all smoothly transitioning, at least tangent. So let's do this again. Okay, and symmetry works quite nicely in Fusion 360. In this form, even when it's patterned that often. Nope, I need to select my... Oh, my selection filters are okay. So when you move anything around now, it's still all symmetric. So now we finish the form. So, and now we need to cut our tile out. So, before I do this, I quickly reverse the surface normal. I'm not sure this is entirely necessary, but it's just good practice when you work with surfaces. So, and this is the reason why I created that second rectangle in the first sketch. So, what one would assume now, you could just use the boundary fill tool. Actually, in order to use that, you would have to create a surface first that would define that boundary. And one would assume now that you could use the boundary fill tool to create a solid from this. But after a little bit of thinking, the boundary fill tool shows that it has selected the two tools, and usually it gives you a green inside with a check mark to tell you that you can select this cell. And then you click on select and you can select that cell. But in this case, the boundary fill tool fails. And the next thing you might try, and that's how I actually found the problem after a long time of looking around, we could just split the body. There it is. We can already see the problem that is not one continuous edge which it should be. And while it's not visible in the viewport right now, there's a super tiny sliver face that will create really strong problems in the next few workflows. So we're not going to use split body or boundary fill. We're going to approach that completely different and maybe somewhat convoluted. What we are going to do is we are going to simply select all our body faces, not all of them. We keep our center tile, this one here. I'm just going to select all the other faces and delete those faces. So that way there's no sliver face created by trying to boundary fill or cut anything. So now if I select this edge here, it's one continuous edge, so there's no sliver face. So then the next thing is I'm going to create a sketch. And just make lines from here to there. And the purpose for those lines is to simply create a surface patch and patch this up. So we need to disable chaining. And then we need to stitch all this together into a solid. All right, so there's our solid. But that's not our final solid, because we could pattern this now, but later on again would get problems with combining bodies because these faces aren't flat. And when patterning and combining, we'll get into trouble. So what's the workaround for that? So the best way I've found to do this is use the offset tool. And just use offset the surface by 0.2 millimeters or so. And now I can use that rectangle here to split this body. And that creates 4 additional bodies here at the corner. We don't need those, so we remove them. So now finally we have our base tile. So what we need to do with this base tile, because I'm going to create sketches here on these origin planes, I don't want to have to create new planes. I'm just going to move that tile to the origin. So there it is. And of course I have a body in my top level, but what I later on want to do, I want to pattern components so I don't create that much geometry. So I'm going to create a component real quick and just move the body. Actually, that's not what I'm going to do. I'm going to use the boundary fill tool just in case to create a copy of that body. Actually, I'm not going to do that because I need to create yet another component, because this would be my upper half. Oops. But I want an upper slice. So that's what I'm going to create that copy in. And the reason why I'm using boundary fill instead of copy paste or just drag this here, you can't edit the copy paste feature. So if you do some surfacing work and that body that you later on create, the solid body, has a different index, then that kills your timeline. All the operations after the copy paste feature are broken because you can't edit the copy paste. So that's why I'm using the boundary fill to duplicate that body here, and now I can remove this one. Okay, so with this one we can now work. So now we have our base tile. How do we get this into the curved shape? It's actually pretty simple. Oh, come on. I'm going to undo that because I have no idea if that sketch was created on the plane that I wanted to create it on. This plane. So create a line, make that maybe 5 millimeters long, and create an arc. And I had already created myself a user parameter. So the radius of that is, because I want to have 40 of these slices patterned. And the tile is 10 millimeters wide. Then I need to divide it by pi, divide it by 2, and that's the radius of that circle. And I will make sure that I have a complete quarter circle. Right, don't need the origin right now. Oops, don't need that origin or that origin. And what I'm going to do now is I'm going to create a sheet metal flange. But before we do that, that sheet metal rule here that I created, the thickness is not so important. It just needs to be thick enough so that it covers the complete thickness here of these T-spline surfaces, or this solid body now. But the important thing is that the K factor is exactly 0.5. So having that said, I'm going to create a little flange. And we make that also maybe 5 millimeters minus 5. Oops, I forgot one thing. I make this symmetric. Okay, and I need to undo that because I forgot something. I need to pattern my tile. So I want to pattern this body along this direction. I want spacing, and I want oh yes, that doesn't make any sense. So of course I want the distance to be 10 millimeter, and the number here is okay. So there's our tile pattern, and now I'm going to create my sheet metal flange. And I'm going to unfold that sheet metal flange. And now I'm going to combine all these tiles with that sheet metal flange. And it's important to note that the sheet metal flange is the target body. So we end up with a sheet metal body. And then I'm going to simply go back into the sheet metal environment and refold that face, that object. And back into the solid workspace and split body. And just split off this flange, remove it because it's not needed anymore. So then I need another sketch. And here again I create a sheet metal flange. And then the rest is pretty simple. Go back into the solid environment and split the body again. and then remove that flange here. We don't need this anymore. So, so the next thing I need is actually a construction axis, and I'm going to pick the axis perpendicular to phase at point. I'm going to look at my sketch here, not this one. Sorry, actually one of those sketches, the second one, this point. And what I don't quite understand is that I cannot pick a construction plane. That seems really silly to me, that I actually have to pick the face of a solid body, or maybe also a surface. But anyway, so now I have my axis that I can pattern around. And I'm going to just pattern. And yet again, that's a circular pattern. Pattern this component around this axis. And I think I've said this already, numcirc is just 40. So if you make the mistake of pattern this as bodies, as we can see, Fusion already, by working with this object, already consumes 8 gigabytes of memory. If you're so unfortunate that you use bodies to pattern this, it'll eat your memory alive. It'll go 16, 20 gigabytes, easy. So the next thing we're going to do to get that lower half is yet another circular pattern. And we're going to pattern this component around this axis only twice. And there is our object. So what colors and what materials did I apply to get to that rendered final image? As I said earlier, I will not cover how I created this T-spline up top, the leaf pattern. That's pretty straightforward. So the material is basically a gold material. And the only thing I did, I changed the color of that gold material to something reddish. So there's that red color. And in the render environment, actually that looks a little brighter than the initial image that I created. So let me make that just a little darker here. Yeah, that's better. That looks more like the metallic red I was looking for. So if I render this now, what I actually inserted into this is an external HDRI, and that's a St. Peter's Cathedral or Basilica, which has more complex lighting than any of the HDRIs that come with Fusion 360.